Hey guys, welcome to my channel and I'm back again with another really interesting video guys. In this video, we are going to fine tune the newest Microsoft Phi3 model with a very interesting low code tool which is called as LlaMa-Factory. So without taking any time further, let's get started with exploring LlaMa-Factory. So guys, let me get started with this tool here. So basically guys, LlaMa-Factory is nothing but a GitHub repository that has been created by some people, which I am not sure who are those people, but you can see here that this is the link for LlaMa-Factory and I will definitely share that in the description below. Now if you go to this GitHub repository guys, you will see that they have actually created a video as well of how to use LlaMa-Factory. But we are not going to watch this video because I will show you how you can use that. But if you just explore through this GitHub link, you will see what all features LlaMa-Factory actually provides. So basically you can see that you can train multiple models with this tool. For example, LlaMa models, for example a Microsoft Phi models, for example Mistral models, etc. And then there are multiple fine tuning methods that you can explore. So you can have supervised fine tuning, you can have reward modeling, you can have DPO fine tuning, all sort of different fine tunings are present. And then bit-wise also you will get 32-bit tuning, 16-bit tuning, 16-bit LoRA tuning, etc, etc. Now there are multiple fine-tuning algorithms that you can use. So you can see that all these algorithms are mentioned here as well, and you get all these options when you try to fine-tune using LlaMa-Factory. You get all these options which you can actually modify while tuning your model. Okay. And then another thing is that some of the tricks that they use, for example, they use flash attention to mechanism, they use unsloth models, and all these, especially these two things, they make your training very fast. So that is one striking feature, flash to attention and unsloth model that they actually use as tricks in their repository. And then there are certain other tricks that they have mentioned here. And then you can try to track this with the help of WAN-DB that I have already done a video before. And once you have trained your model, they also provide you a way to actually test those models. So you can actually use Gradio UI, you can use OpenStyle APIs to actually do a inference of those models, or basically test them out or chat with the models to see how they actually work. Okay. And then here they have mentioned that certain models that have been trained with the help of LlaMa-Factory, how well they are performing on benchmarks. So you can see that LlaMa-Factory model is in dark blue color, and it is being compared to some P tuning model here. You can see that it performs 3.7 faster training speed, and that's a really good score as compared to other type of techniques. And it uses a 4-bit quantization, which I have mentioned before, that it uses multiple bit quantization you can actually choose, but by default it chooses 4-bit quantization. And for example, it's used LlaMa-Factory's QLoRa's technique. Okay. And then there is some change log here. They have mentioned all the supported models that you can fine tune. They have mentioned all the training approaches, all the type of fine tuning data sets or pre-training data sets that you can use, all the requirements that you need to actually run this repository, all the hardware requirements as well. And there are certain steps which you might need to get started with it. However guys, there are two ways that you can get started with this. One is that you can clone this repository on your local machine as they have given the steps. But let me tell you one quick thing about this guys, that LlaMa-Factory is a repository that needs GPU to run. Okay, so if you don't have GPU on your local machine, unfortunately I don't think you can use LlaMa-Factory on just a CPU machine. So in that way guys, you need either a free Google Colab where you can actually run this, or you might need a paid account on HuggingFace or somewhere where you can actually try to use this LlaMa-Factory. Okay. Now Let's first quickly see how you can open this LlaMa-Factory in HuggingFace Spaces. So let me show you this link here. It says open in Spaces. Once you click on this link, guys, you will see that this space gets open in HuggingFace. So basically they have created this HuggingFace space where you can use fine tuning with LlaMa-Factory with no code. So this is like absolutely just selection of certain parameters, and you can start to fine tune your model. You can see this is how this space looks like. If you want to use it on HuggingFace, guys, then you can't use it directly. You have to actually go to these three dots here. Let me show you the three dots. Yep, there you go. You have to actually duplicate this space. Once you duplicate this space will be actually cloned on your own HuggingFace account, and then you will be able to run it. But remember, guys, that it will only work if you have a HuggingFace account which has got GPU enabled. Okay, so when you are going to duplicate this space, you actually have to select the GPU option, which is a paid option in HuggingFace. You can select the CPU option, but you'll get an error. Okay. We are not going to use this space in HuggingFace, but we will still use it for one small thing, and that is to take a reference of how we can use the similar repository, or basically exact same repository, on a Google Colab. Okay, let me not confuse you further. First, let's go into it and you will get to know it much better. Okay. So now you have already seen one way of using LlaMa-Factory, that is using HuggingFace spaces. Now I will show you the free way of using LlaMa-Factory to actually fine tune your Microsoft Phi model, and that is using Google Colab. So if you see this link here, it says open in Google Colab. You can actually open it, and it will open the entire LlaMa-Factory's Google Colab code on your machine, and it will look actually something like this. So you can see that I already have that Google Colab open with me, and I already ran it. So I'll just go through this and I will show you how it actually looks. Okay, so first thing first, guys, that whenever you are running this Google Colab repository, you need the T4 GPU to be enabled. So if your runtime is not running on T4, you have to select here and connect to a T4 runtime. Okay, or change the runtime type to CPU. Now let's go through this Google Colab repository, and let's actually train our Microsoft Phi3 model with this. Okay. So the repository is very simple, guys. You will see that the first step is just installing the dependencies, and if you could just do it on your local machine, you will do it the same way. Basically, you are cloning the LlaMa-Factory Git repository on your machine, and you are just doing the necessary installs. And you can see here that you are using unsloth Git as well, which basically makes your training much faster. And you are getting the X transformers here, you are installing the bits and bytes here. Okay, so it's pretty simple installation. Second is check your GPU environment. So I told you before that LlaMa-Factory can't be used on a CPU. So the next step is very important, that you must have a GPU environment running, and here it just says that if your GPU is running, return true, otherwise it throws an error. And then the third step is a bit optional step, guys, which they have given in this repository, is to update an identity dataset. So basically they have created their own identity JSON dataset where they are just updating some values here, and finally they are dumping those values, and that dataset is just saved here on your Google Colab. Okay, but this step is optional. So if you don't want to use identity dataset, then you don't actually have to do this step also. Okay, because you can just use existing datasets to actually train your model. Okay, so you can actually skip this step if you don't need it. Basically this is just updating the identity dataset here. Okay, cool. Now let's go to the next step here. The next step is fine-tune model via LlaMa Board. Okay, so what is this? So basically, guys, if you have a Google Colab and you are running this and you don't have much idea about code, then you can actually use a UI to basically train this model. Now if you run this cell, guys, you will see that certain logs are going to appear, and it is going to give you a public URL. Now if you open this public URL, obviously now it's not working, so it will not open, but if you open this public URL, once this cell starts to run, you will actually get an exact same user interface as that of the HuggingFace LlaMa Board space, which I am just showing you right now. And from here also you can actually select your model, what you want to train, and do a certain configuration, and you can finally press this start button and you can start the training. In case you don't want to use the Google Colab, but I do find Google Colab running much easier than actually running it with UI. So that's why I didn't choose this method, and I have not tried even training with this method. But if you guys want to try it, once you run this cell, you can just go to this link and select your choices of model, select your choices of dataset, and just start training the model, okay, by clicking on the start button. But let's see how we have actually done this. So this is the command to actually fine tune the model by your command line. So here you can see, guys, there are certain arguments that we are actually giving to our model. Obviously, what type of training you are doing, which is SFT in this case, what is the path of the model or the name of the model. In this case, I have given the HuggingFace path of the Phi3 model, which is the latest model released by Microsoft. Then the dataset. So obviously, guys, the identities dataset is the dataset which we just updated, and that identity dataset you can provide, and you can also provide the so you can provide multiple datasets. So one is the identity dataset that they have provided, and another dataset is Alpaca GPT-4 EN dataset, which is one of the supported datasets by LlaMa-Factory. So you can select your supported dataset, and you can select this identity dataset as well. Then they have got the supported models, right? So LlaMa-Factory supports a certain type of models, and for each and every model they have a certain template, or which they call prompt template, right? So because we are training Phi3 model, the template has to be Phi. Ignore the comment here, guys, which says use LlaMa 3 prompt template. It has to be Phi3, guys. But when I actually cloned this notebook, when I copied this notebook from LlaMa-Factory, all these parameters were very specific to LlaMa 3 model. So I just changed these parameters to fit to Phi3. So you can just ignore the comments there. And then what is the fine tuning type? You can select different type of fine tuning, guys. I have selected the LoRA fine tuning because again this was the default tuning which was given by this notebook. You can select a different type of fine tuning. At some point in time we will actually also dive deeper into what different fine tuning actually means, but for now let's keep it very simple. Okay, then finally the output directory, guys. So this is the output. So when, if let's say if I expand this, you will see that there is an output directory that gets created here, Phi LoRa, where you are Phi3 LoRa, where actually after training your model will get stored. Okay, and rest of the things are pretty much your hyper parameter tuning, guys, like the gradient accumulation, the training batch, the warm-up ratio, the train epochs, the maximum samples, etc, and FP16 obviously, because we want to specify the bit precision here, and you can see that we need FP16 for this. Okay, but once this is done, it will actually store everything in this Phi LoRa. Okay, and if you actually open the data folder, guys, you will see that all these identity dataset, the Alpaca dataset, when you specify the Alpaca dataset, entire dataset gets downloaded in this data, and even your identity JSON is present in this data folder. Okay, so if you want to have your own sort of custom dataset, if you want that, then you can actually update one of these JSON files here, and then you can mention that. So for example, if you update the identity JSON with some of your own data, you can mention the identity file here, or you can create your own JSON file and you can mention that file. So in that way you will actually be able to train your model with your custom dataset also, and also with a pre-trained dataset. Okay, or pre-selected dataset. So let's see guys how it works after that. So once you have your arguments, simply you do json.dump and then train llama 3 json indent 2. So basically it creates a json of your argument and it puts it in train llama 3 json. And finally this is the command. So you give LlaMa-Factory CLI the parameter train, which means train, and then you give the JSON. So this JSON of all the hyper parameters goes into this as an option, and finally your model starts to train. Okay, now let's look into how this model is actually training. Okay, so you can see that it starts to train slowly and steadily. It trains all the parameters. It finally does all the epochs. It does all the samples as provided by you. And finally, it says that your model is completed. Okay. So all the training is done and it drops some of the result as it does not have the necessary fields. I'm not sure about that, but eventually your task gets ticked, right? So, and you can see guys, it's very important to see here that Phi3 is not a smaller model, it's a bigger model also, but within 15 minutes, within only 15 minutes guys, we were able to fine tune this model with our data set. So how quick was that? This was actually super quick guys. And one more thing I want to show you, that once you actually train this model, you can use this model to ask questions. You can use inference, and to use inference guys, again we will use the LlaMa-Factory APIs only. So you can see that first we created a argument structure here where we give the model name, we give the path. So now the path of my model is QLoRA, okay, because my model is now stored in this folder. Again, we give the template, we give the fine tuning type, the quantization bit, the use unsloth, because I told you that we use unsloth LoRA optimization for faster generation. Then we give our chat model all these arguments. We give we create a messages list where we will basically be storing the history. And then we say, okay, fine, then start the query where first the user is going to ask the question. Then if you write clear, then entire history will be clear. If you write exit, then you exit the application. And just like that, the messages will go. The messages will be appended here. The query will be appended here. And finally, your model will actually respond. Okay, let me go back here. 1 second. So finally, you can see here that the messages will be appended and the response will be actually generated by your model. So new text in chat model, the stream. So the messages will go into the chat model and the response will be generated, stored into the new text, and new text will be your response. And finally, you will see all the results. Let's see how it actually worked for us. So I'm the user, I wrote hi, and the assistant wrote me, hello, I am LlaMa 3, an AI assistant developed by LlaMa-Factory. How can I assist you today? So you can see that it says that I am LlaMa 3, but actually I'm pretty sure that there is some place where I have written LlaMa 3. That's why it's saying that. Otherwise, it should say I am Phi3 and not LlaMa 3. Not sure where that small change is, but I'm pretty sure that this should be actually Phi3 and not LlaMa 3, because you can see here guys that the loader adapter is Phi3 LoRA, so obviously it is taking the Phi3 model. Okay, you can select here and you can see all the model values, all the details are actually Phi3 models. Fine. Okay, so now you can actually now chat with this model guys. So let's say if you write here what is 4 plus 5. Okay, let's say I am asking it a math question. So it says 4 plus 5 is equals to 9, and you can see that now it works. So write me a one-liner joke. Let's say how it responds to joke. Okay, why don't scientists trust atoms because they make up everything, which is well, not that funny joke, but I will still take it. But you can see here, guys, that within 15 minutes we were able to actually train our model. We are able to actually fine tune our model, and also able to do it with the some amazing data sets like alpaca, some of our custom data set like identity, without writing a lot of code, just like a very small amount of code, and we were able to do it. Okay. Now, uh, now that we know how to fine tune this model, and now we have that knowledge in our mind, I want to also understand one more thing, guys. That is, how do we actually come up with these arguments? Which could be a question in you guys' mind as well. That how do we actually come up with these arguments? So let's say if you want to train a different model, for example, now Phi3 just came and then LlaMa 3 has been launched. So you want to train a model, but you don't know what arguments you should get, right? So the best thing to do is you just go to actually the HuggingFace base of LlaMa 3, LlaMa-Factory. Now from here you select the model. So let's say here if I select Mistral, right? So let's say if I select Mistral 7 billion, right? And it will give you the path, whatever. Now you select the fine tuning model. So let's keep the fine tuning model as LoRA. And let's say here I change the stage. So I change that it should be a DPO fine tuning. I keep the data set as comparison data set. And also I change the batch size to, let's say, 5. I change the gradient accumulation a little bit less, and I change the cutoff length to, let's say, 2048. Okay. Now I have created all these values, right? So now I want to, now I have created all these values. So now I want to look at the command. Okay, I don't want to actually train it with this. I just want to look at the command. So you can see here that now I have got all the command values here. So I have got the stage value, I have got the template also, which is default in this case. I have got the model name. So everything that you want in this in these arguments, you can actually copy paste it from the LlaMa board, so that you are sure that these values are going to work. Because sometimes it happens that you don't know what template you want to use, you don't know what is the value of let's say the fine tuning type, if you change the fine tuning type, so you don't know some of the values, right? So in that situation you will be actually be able to you'll actually be able to write the correct values with the LlaMa board copy. Okay. And finally, guys, if you want to actually upload this model to HuggingFace, I'm not sure LlaMa-Factory notebook allows you to upload it just like that, but you all obviously have the model with you in this directory Phi3 LoRA. Okay, so you can obviously copy paste this. You have got all the tokenizer and everything here, so you can actually, and the safe tensor file as well. So you can actually copy paste it and upload it on HuggingFace base and try it out from there, because then you will be able to just load it from HuggingFace base also, and you can use it with the help of LlaMa-Factory to actually do inference on your model. Okay, but if in future they actually give us a much simpler way of uploading our models to HuggingFace, I will be looking forward to it and will make a video on that as well. But for now, guys, I hope you guys like this video, and I hope you learned something from it, and I hope you will also be using LlaMa-Factory to fine tune your models. If you do, guys, then please do not forget to write down in the comment section below about your experiences, and if you have any questions, comment, feedback for me, please do write down in the comment section as well. If you like this video, guys, then please do not forget to like this video and share this video with your friends. And guys, in the end, if you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, guys. Until then, take care and bye bye.